Continuing, reading through the Electrical Safety Student Manual. Approach boundaries. The risk from exposed live parts depends on your distance from the parts. 3 boundaries are key to protecting yourself from electric shock, and 1 to protect you from arc flashes or blasts. These boundaries are set by the National Fire Protection Association, NFPA 70E. The limit approach boundary is the closest an unqualified person can approach, unless a qualified person accompanies you. A qualified person is someone who has received mandated training on the hazards and on the construction and operation of equipment involved in a task. The restricted boundary approach is the closest to exposed live parts that a qualified person can go without proper PPE, such as flame-resistant clothing and insulated tools. When you're this close, if you move the wrong way, you or your tools could touch live parts. Same for the next boundary. Prohibited. The prohibited approach boundary, the most serious, is the distance you must stay from exposed live parts to prevent flashover or arcing in air. Get any closer and it's like direct contact with a live part. Electric shock boundaries to live parts for 300 to 600 volts. Prohibited approach boundary is 1 inch. Restricted approach boundary 1 foot. Limited approach boundary 3 feet 6 inches. Remember, limited approach boundary is the closest an unqualified person can approach unless qualified person accompanies you. That is 3 feet 6 inches and no closer for an unqualified person. The restricted boundary, which is the closest to the exposed live parts a qualified person may go without PPE, without proper PPE, is 1 foot and no closer. But the prohibited approach boundary is very close. The distance you must stay from exposed live parts to prevent flashover or arcing in the air is 1 inch. Approach boundaries. To protect against burns, there is 1 more boundary, the flash protection boundary. This is where you need PPE to prevent incurable burns if there is an arc flash. The flash protection boundary for live parts for 300 to 600 volts is 4 feet. Remember, overhead power lines can kill many workers. Keep outside the flash protection boundary. You see here, this worker is within a certain distance from where the arc flash had occurred. This can result in physical injuries as well as burns. Overhead power line hazards. Most people do not realize that overhead power lines are usually not insulated. More than half of all electrocutions are caused by direct worker contact with energized power lines. Power line workers must be especially aware of the dangers of overhead lines. In the past, 80% of all lineman deaths were caused by contacting a live wire with a bare hand. Due to such incidents, all linemen now wear special rubber gloves that protect them up to 36,000 volts. Today, most electrocutions involving overhead power lines are caused by failure to maintain proper work distances. You see, for example, here you have the 3 high voltage power lines above from 3-phase supply. You have the transformer. This would be a step down transformer and steps down the voltage to a low voltage. For example, it may be 24,000 volts on the high voltage side and 240 volts between live and live on the low voltage side, 120 volts between live and neutral on the low voltage side. Watch out for exposed electrical wires around electronic equipment. Electrical line workers need special training and equipment to work safely. Shocks and electrocutions occur where physical barriers are not in place to prevent contact with the wires. When dump truck, crane, work platform, or other conductive materials such as pipes and ladders contact overhead line wires, the equipment operator or other workers can be killed. If you do not maintain required clearance distances from the power lines, you can be shot and killed. The minimum distance for voltages up to 50 kilovolt, which is 50,000 volts, is 10 feet. For voltages over 50,000 volts, the minimum distance is 10 feet plus 4 inches for every 10,000 volts over 50,000 volts. Never store material and equipment under or near overhead power lines. You need to recognize that overhead power lines are a hazard. Operating a crane near overhead wires is very hazardous. You can see the crane here, and it's near to the overhead wires. You have to be very, very careful if that's what you find yourself doing one day. Case: 5 workers were constructing a chain link fence in front of a house directly below a 7,200 volt energized power line. As they prepared to install 21-foot sections of metal top rail on the fence, one of the workers picked up a section of rail and held it up vertically. The rail contacted the 7,200 volt lines and the worker was electrocuted. Following inspection, OSHA determined that the employee who was killed had never received any safety training from his employer and no specific instruction on how to avoid the hazards associated with overhead power lines. In this case, the company failed to obey 3 regulations. Employers must train their workers to recognize and avoid unsafe conditions on the job. Employers must not allow their workers to work near any part of an electrical circuit unless the circuit is de-energized, that means is shut off, and grounded or guarded in such a way that it cannot be contacted. Ground fault protection must be provided on construction sites to guard against electric shock. So this is an illustration of what happened in the electrocution of the fence installer. The long metal rail touched the overhead power line. Electric current would pass through his body to the ground and electrocuting him. Defective insulation hazards. Insulation is material that does not conduct electricity easily. So in this case, we're talking about the rubber that is around the copper in the wire, or around the aluminum. Defective insulation hazards. Insulation that is defective or inadequate is an electrical hazard. Usually a plastic or rubber covering in insulated wires. Insulation prevents conductors from coming in contact with each other. Insulation also prevents contactors from coming in contact with people. Extension cords may have damaged insulation. Sometimes the insulation inside an electrical tool or appliance is damaged. When insulation is damaged, exposed metal parts may become energized if a live wire inside touches them. Electric hand tools that are old, damaged, or misused may have damaged insulation inside. If you touch damaged power tools or other equipment, you will receive a shock. You are more likely to receive a shock if the tool is not grounded or double insulated. Double insulated tools have 2 insulation barriers and no exposed metal parts. A damaged live power tool that is not grounded or double insulated is very dangerous. If you touch any damaged live power tool, you will be shocked. You need to recognize that defective insulation is a hazard, and you see the arrow here pointing to a section of the insulation that is damaged. This extension cord is damaged and should not be used. At this point, we have reached improper grounding hazard. We will read improper grounding hazard in the next video.